lesson. And we finished, before we went to lunch, we did that 20 or 54, and now we're gonna do 57. I know I used some of that space, so I'm just gonna kind of mark it off. Everybody doing okay? Yep, as well as we can. Awesome. Okay, so 57, it says, Julie Stone designed a rectangular patio that is 25 feet by 40 feet. This patio is surrounded by a terraced strip of uniform width planted with small trees and shrubs. Did you make it? No? Yes? No, not at all. Not at all. Nice. Okay. I was going to celebrate, but I guess not. Planted with small trees and shrubs. If the area of this terraced strip is 504 feet squared, find the width X of the strip. So we got to draw a picture first. So I just explained a lot, but basically this lady has a patio, and then she put like a strip of plants around it. Okay, so I've got this rectangular patio, and it's 25 by 40 feet. So that's like a cement patio. We put chairs and all that fun stuff around it. On the outside of that, in like a nice little frame around it, she has a bunch of like plants and shrubs and little trees, but it says it's a uniform width, which means that from all sides of the patio, it's the same. So I'm going to use X to represent that. So it's X in this direction, it's X in that direction, it's X in this direction, and it's X in this direction. Mine might not be great to scale, but it's as good as we're going to get. What it wants us to do, it tells us that the area of this strip is 504 feet squared. And so I want to find the area of all of that on the outside. I do not care about this patio that's on the inside. I'm going to essentially kind of cross him out. But I know that the area of all of that blue frame on the outside is 504 feet squared. Now, this may not be the most conventional way, but this is what I thought was the easiest way of doing this. Is what if I broke that square, or yeah, that like square with the middle cut out into like little pieces and found the area of each of those pieces and then add them together. So let me demonstrate what I'm thinking. So what if I took like this rectangle right here? That should be the same as like this over on this side. If I can find the area of those two things, then I'll be able to add that to what I already have. I'm going to draw that little rectangle off to the side. I'm essentially breaking this apart and doing like bite-sized pieces of this rectangle. This, I know from my picture, is X wide, so I'm going to put an X for its width. And then its length is based on the patio, and the patio goes from something to 25 to something else. Each of these are X, and then the middle we know is 25. So the length of this patio, or this little pink strip that I made, is 25 plus 2X. You okay with how I cut this piece up so far? How many of those pink rectangles do I have in my total area? 2. So if I write this expression area, I'm going to have to multiply it by 2. The area of that little strip would be X times 25 plus 2X. But since, as May told me, I've got 2 of them, I'm going to make it a 2X on the outside, 2 times all of that. Because here's one, and here's the other one. Each one is X by 25 plus 2X, and so I just did 2 of them. And then I want to do the little pieces that are still left, this. Which that little rectangle is going to be, it's not as pretty, but just deal with me. that's with this distance is also x, so I'm going to write x there. And then how long it is, well, the length of my patio there is 40. And I go just to the 40 because I already take care of the x's with the pink part. So I've got x and I've got 40. My area of that would also be x times 40. But how many orange blocks are there? 2. 2x times 40. This is what came to me first. What I guess you also could have done was done the area of the whole outside. Let me erase some of this nonsense on the inside. I'm going to finish solving it this way, but if you would rather do it differently, you could have done the area of the entire outside, and these outside measurements would be 40 plus 2x. And then this one would be 25 plus 2x. And then we'd have to minus out my 40 times 25. So that is also an option. I could do what I'm about to do right here, or I could have done area is 25 plus 2x times 40 plus 2x minus off 25 times 40. It should give you the same answer. I, for some reason, thought about piecing it together first, and you don't have to know certain formulas or anything in order to move on from that. So I was like, okay, let's see if I can break it apart, and I thought that made more sense to me. So that's what I decided to do. Either way is fine. I'm going to keep going this way, but you should get the same answer. And I'm going to do, well, I know my area is 504, so I'm going to set this expression equal to 504 equals 2x times 25 plus 2x plus 2x times 40. And then I'm going to start simplifying. Distribute that 2x in, multiply that 2x there. 504 equals 50x plus 4x squared plus 80x. I'm going to see if I can simplify there on the right-hand side. I've got 504 equals 4x squared plus 130x. And actually here, I want to graph. Sometimes we mess up if we do quadratic formula. Sometimes we mess up if we do too much factoring. So I want to graph this and see what my intersection of these is. I have one equation, 504. That can be my y1. That's just going to be a straight across line. And then I've got my other equation, which is 4x squared plus 130x. That can be your y2. We're going to see where they intersect. For sake of time, I'm not going to switch back to the calculator. So if you have your calculator, you can listen to me, or I'll try and put on the little video thing. But I'm going to make sure my all my y's are canceled out and my stat plot is all emptied out. And I'm going to graph 504 for my y1, and then 4x squared plus 130x for my y2. And before you even graph, you're going to know you have to change your axis, because my window, if my 504 is one whole horizontal line, I need to get at least above 504. I'm probably going to go to 1,000. I'm going to go 0 on my y min to 1,000 as my y max. And then, I don't know, I'm going to keep my x's the same. We'll see what happens. Okay. I know those of you at home maybe can see this. I don't know if you at school can see this. I've got like a straight line and then like a curved line. And then I'm just going to find where they intersect. So I just graphed the two equations, made sure my window showed both of them, and then I'm going to do my intersect. Second trace 5, first curve, second curve, enter. My intersect is at 3.5, 504. Intersect 3.5, 504. Which one of those numbers do I want? Which one? 3.5. The x represents how wide that little strip is. So the strip is 3.5 feet wide all the way around. Bless you. Mm-hmm. I wrote that because I wanted you to go back to your notes and know what was happening. Mm-hmm. Yep. And you should get the same thing the other way too. If you like the idea of starting big and then subtracting off what you have, that method is good. I, for some reason, when I first looked at it, was like, oh, I'm going to try and build apart what I have. So I thought about adding the pieces. You're going big and subtracting. It's the same thing. It just looks a little different. You'll get the exact same answer. All right, let's go to the next page. We're going to skip and do 62 together. And then if I have some time, I'll look at the other two at the above that. The reason I skipped to do 62 before I did any of the other ones is because we've done problems like this. This is on your chapter P test. It says a baseball throwing machine. Sandusky Little League uses baseball throwing machines to help train 10-year-old players to catch high pop-ups. It throws a baseball straight up with initial velocity of 48 feet per second from a height of 3.5 feet. Back in unit P, we did an example like this, and I gave you the general form of a quadratic projectile motion problem. The general form is y equals negative 4.9 x squared. Sometimes we use t, but I feel like using x today. Plus v with a subscript of o x, and then plus s with the subscript of o. That v and s are basically physics terms. So if any of you take physics, this is probably not that crazy or new or different. I have never taken physics. I don't know how I made it my whole life. I never tried to take physics. You in physics? Oh, yeah. Sorry, I thought you were trying to tell me something. The VO means initial velocity. So if it has a subscript of 0, it means it's initial or where it is at the start, and the V stands for velocity. So I'm going to zoom in and write that real quick. Initial velocity. And then S0, I don't know what the S stands for in physics, but I've always called it like initial place or initial height. In this case, it's height, but sometimes it's like its placement, so whatever makes you happy. And this was on your P test, and I gave you that formula, and then we just plugged in. So if I tell you that, then we just plug in here. My initial velocity is 48 feet per second, and my initial height is 3.5 feet. So we're just going to plug that in for V sub 0 and S sub 0. That's going to be my equation. So A is about to be my equation. A, y equals negative 4.9 x squared plus 48x plus 3.5. Cool with that so far? Then part B says, what's the maximum height the baseball will reach? How many seconds will it take to reach that height? What do you think we should do? Let me find, exactly, put in the calculator, graph it. Find the maximum on your calculator. If I told you that its initial term was a negative x squared, that means it's going to be a negative even, so it's going to be a downward facing parabola. We're going to find an easy maximum on that. Easy. Calculator. So I'm going to my calculator and I'm going to go plug in, get rid of all the other y's. Negative 4.9 x squared plus 48x plus 3.5. I'm gonna leave my window alone and see if I need to make adjustments later. So I'm gonna graph it. You can't really see on mine, but it's like way low. Like I can barely see it. So I'm gonna go zoom down a little bit. If my window was at 1,000, let me put it at like 300 and see what happens. It's a little bit better. I can even go down to 200, I think. The only thing that's weird on my calculator right now is that I have all those negative spaces out there. What you guys see in class is like a reflection of what it is. Does that make sense? It's like flipped, I think, right? I don't know. I think I can't think that straight today. Whatever. Can we find maximum? Yes. Let's find it. Second trace max. Left bound, right bound. Yes. And it gives me the point 4.9 and then 121.1. Do you know what my X represents? And what my Y represents? Y is not the time. X is the time. X is generally the time. You're right, Parker, that one of them is the time. This time it's my X. And then when X is time, Y is usually distance. And in this case, it's my height by feet. So it asked me in the problem, what's the maximum height and how many seconds will it take? So I'm going to write over here, maximum height is 121.1 feet, and it happens at 4.9 seconds. This is not something you'll see on the quiz tomorrow, but this is something that will for sure be on the test or maybe even the next quiz. So we got to know how to do these and be ready. All right, I think that's all we have time for today, right? Doesn't class end in like a minute? Okay, you cannot do all of 2-1, but I do want you to start it because that will help you prepare for your quiz. So the 2-1 that you cannot do is number 2. Skip number 2 on the 2-1 homework. Your 2-3, all of it is due tomorrow. The 2-1 I haven't technically assigned yet, but I would get started on it because that will help you do well on your quiz tomorrow. Skip number 2 on the 2-1 for right now. Everything else you need to be prepared to do tomorrow. All right, any questions? Don't forget canned food drive tomorrow and Friday, last chance. All right, let me come over, spray down your desks. You can put everything else away. Okay. I started my last class, but I'm really feeling the effects of daylight savings. Anybody else just kind of like blah? I was I'm just so sad when it's pitch black at 6 p.m.
It's just really
Like, what does it look like outside now? Is it nice out?
sun setting during football practice.
I guess it is kind of sunny out. Like, I like sit in this box all day, and then I go home when it's dark out, and I'm just like kind of depressed. And normally this doesn't hit me until like I'm not really sure what I'm gonna do. That one. You should teach outside. You should teach outside. I only had a little whiteboard out there for me to do it. Here, go for your table.
No. Yeah, one. It's always a weird state part.
I was sitting there.
Bye, guys. Have a good day. See you tomorrow.
Thank you. Bye.
Bye, Janae. Thank you, Gabby.